Lads, so this is what's known as the equation of a circle. Okay, so you go to the circle part of the notes around page 18 and 19, and you'll see a generic formula for a circle which says x minus h squared y minus k squared equals 169. Right? So what this means is that, x squared y minus k squared equals r squared. Excuse me, all right? So what you're going to notice is that instead of r squared, you have 169. This means that r squared equals 169. You square root it, and you get 13. Okay? So r equals 13. Okay? Now, in this formula, you'll also see that it reminds you that hk is actually the center of the circle. So instead of h, we have the number 4. So that means that 4 must be the x value for the center of the circle. Instead of minus k, so you see minus k, instead of minus k, we have plus 2. And because minus k equals plus 2, when you multiply both sides by minus, k has to equal minus 2. So that center of the circle, oh, that's great stuff. Nope. Undo. Okay, back in a second. Okay, so that's 4 minus 2 is the center of the circle, and the radius is 13. Happy days. Now, the point is the point 11, 10 on the circle. In the circle or outside the circle, show you're working now. So, in order to figure out if something is inside or outside the circle, you need to get the circle's formula, which is x minus 4 squared plus y plus 2 squared equals 169. Now, what you generally do is you replace the x value and the y value with the point you want to test. So we want to test 11 and 10. So it's going to be 11 minus 4 squared plus 10 plus 2 squared. Okay. Now the deal is, if both sides balance, it's on the circle. If the blue side is, for argument's sake, bigger than the red side, it's outside. Okay. And if the blue side is smaller than the red side, it's inside the circle. So you're going to use your calculator, and what we're going to do is 11 minus 4 squared plus 10 plus 2 squared, and we get 193. 193 is greater than 169, and what we're going to do is we're going to say it's outside. Okay, now we're on to B part 1. Here we have two circles, S and T. The circle S has a center of 22 and 13, and the two circles touch at the point 12, 11. So they touch here. Now what they want is find the corners of another point on the circle S other than 11, 12. So what it wants me to do is it wants me to find another point on the circle, the large circle. Now I have an idea. Here'd be my idea. If you imagine the diameter of this circle goes all the way out the other side. Okay, so how do you go from 12 up to 22? Well, you must add 10 to the x value. How do you go from 11 up to 13? You must add 2 to the y value. And if we go the same distance out the other side, so we add 10 onto 22, and we get 32, and we add 2 onto the y value, we get 15, because we know that this point has to be the midpoint of these two red dots here. So the center of the circle is the midpoint of the two red dots. That's how we know that this is 32, 15. It has to be the same gap with the x value and the y value. So we know that this point here would be 32. 15 is a good point we could use for that. Okay, next question. The radius of circle T is half the radius of S. Find the coordinates of the center of the circle T. Okay, now this is interesting. Okay, so half the distance. I have an idea. So we go from this green spot down to this red spot. We go now it's green to red this time, not red to green, so it's going to be the opposite direction, okay? So to go from green down to red, it's minus 10 to the x value, because you're going from 22 down to 12, and it's going to be minus 2 to the y value, because you're going from 13 down to 11. Now, what it says is that the radius of t is half as big as the radius of s. So I think that means we should cover half the distance. So instead of doing minus 2 to y, we might do minus 1 to y. And instead of doing minus 10 to x, we might do minus 5 to x. So minus 1 to y and minus 5 to x. So get this. Take 1 away from 12 and you get 11. Right? And take 5 away from 11 and you get 6. I think this point is the point. Wait, sorry, gents. I think I got my numbers mixed up there. It's take 5 from x. So take 5 from x is 12, take away 5, which is 7. And take 1 away from y. 11 take away 1 is 10. So I think that's the point 7, 10. Okay, there you go, the point 7. Okay, so that's question 2 done. Now we're on to question 5. It's an equilateral triangle, means all 3 angles are 60 degrees. So the angle of PQR, the middle letter is Q, so the angle of PQR is 60 degrees. Okay. Show that the area of the triangle is 16 root 3. No bother. We can use a half AB sine C. A half any 2 lengths and the angle in between. So a half 8 times 8 sine 60. So it's going to be a half 8 times 8 sine 60. Okay, so we can bring both of these downwards into our answer here. Oops, sorry, did not mean to do that. Okay, let's try this again. Bring you there, and you down here. Use your calculator. A half 8 times 8 sine 60. And lo and behold, you get 16 root 3. Happy days. Which is what exactly we were looking for. Okay, next part then, part 3. Hence or otherwise, find the perpendicular height of the triangle PQR, taking PQ as the base. Now, the deal is that in this triangle here, it wants PQ to be the base, if you read the question. So PQ, it's the base. So that distance there is the base. And this green line here, that's the perpendicular height. So a half the base times the green height has to equal 16 root 3. Okay. Now we know the base is 8. So it's half times 8, which is 4. This means 4h equals 16 root 3, because we know the base is 8. So 4h equals 16 root 3. And what we're going to say then is that h on its own is 16 root 3 divided by 4. And that equals 4 root 3 centimeters. Question 5a. 5b seems to have a bit of trigonometry in it. Okay, so we'll just shrink the size slightly. So it's a right angle triangle, and it wants me to use Pythagoras' theorem. Now, Pythagoras' theorem is the longest side, which is the 30 squared, equals the other sides squared and added together. We're going to let hk be x. 30 squared is 900, 12 squared is 144, and that's x squared. We want to get the x squared on its own. We're going to do 900 take away 144. And we get 756. We're going to square root that to find out what x is. And x is 6 root 21, or 27.5 centimeters. All right, happy days. That's B. I think there's only one part B, is there? Now we're going to move on. That part B was the easiest part of that question. Now this is question 6. Okay, a circle C is shown diagram, not the scale, and its center is at the point 0. A, B, and D line the circle where AB is the diameter of the circle. Write down the angle ADB. A to D to B. So does everyone see this big blue angle here? Because it's facing the diameter. Okay, so if I was to use this red triangle here, you see that the blue angle is facing the diameter of the circle, and all 3 points are on the circle. This means that this angle ADB has to be 90 degrees. Okay, ADB has to be 90 degrees. Okay, now what we're going to try and do next is we want to figure out if AOD is 130. Where's AOD? So AOD is 130. And what we did figure out is find the size of x. No bother. All right. So this is actually quite easy because this is 50 degrees because of it being a straight angle. Okay. So we say is that's 50 degrees. This is an isosceles triangle. How do I know it's an isosceles triangle? Well, both of these are radiuses or radii. So that means that these two angles are the same. This means x plus 50 equals 180. So that means 2x plus 50 equals 180. 2x equals 130. And x equals 65 degrees. Happy days. The radius of the circle is 18 centimeters. Find the length of the arc AD. Okay, so arc AD. Let's have a look at this. This is the arc AD. Now, does it say minor arc or large arc? See, there's two arcs. There's the major arc and there's the minor arc, and both of them have different answers. Okay, so I'm just going to do a rough diagram for you now, and I'll show you what I'm thinking. All right. So there's two answers here. Okay, so if you imagine that this here is that's A to D from the diagram. Okay, so that's A to D. Okay, and that's 130. Okay, now what we're asked to do is we want to find this arc here. So that's A to D arc here. So that's A and that's D. And we're going to find this arc here. And we know that the radius is 18. Okay, now the length of the full circle, if I was to run a lap of the full circle, and I was to go all the way around, okay, that would be L equals 2 pi r. All right, and in your maths tables, there is a formula for this. See, we have to find out what fraction 130 is. So there's a formula that says theta over 360. This tells you what fraction of the circle you need, and then multiply by 2 pi r. So you're actually going to do 130 divided by 360, multiply by 2. Now it says in terms of pi, so we're just going to use pi from the calculator, and the radius is 18. Okay, and here's what we're going to get. 130 divided by 360, multiply by 2, pi, and then your 18. And then we get 13 pi as a 13 pi. Now that's the answer that's in the back of the book. And that's referred to as the minor arc. There could be a case to be made that somebody else could have came along in the same test and actually done the major arc, which is this yellow one here. The major arc would be 360 degrees, take away 130. which is 230 degrees. And instead of using 130, you'd use 230, and your answer instead would be, what would be the answer instead? The answer instead would be 23 pi. So there's two possible answers for that. The 23 pi is the major arc, and the 13 pi is the minor arc. Okay, good job. Let's keep going. Two statements A and B are shown below. For each statement, put a tick beside the box to show if it's true or false. Give a statement. If two triangles are similar, then they must be congruent. False. Reason. So a good reason would be two triangles. Okay, so this triangle here, right, and Control C. Oh, sorry, I think I can clone this. Clone, right? Control C. So I'm just going to enlarge this. Okay, so similar means the same proportions, all right? So if that's 5, that's 6, and that's 8. If I double this triangle and I get 10, 16, and 12, these two triangles are similar, okay? So A, B, C, and we call this D, E, and F. And what you say is triangles A, B, C, and D, E, F are in the same proportion. So they are both the same shape. And hence similar triangles. Okay. However, they are not identical. So they are not congruent. Okay, statement B. If two triangles are congruent, they must be similar. This is true. As congruent triangles, as congruent triangles have the same three angles as each other, they must also be similar. So similar triangles, okay, in case you didn't get it earlier, similar triangles, the angles are always the same. So if that's 110, that's 110. That's, for argument's sake, that for argument's sake is 40. That will be 30. They're all three angles are the same in similar triangles. And if all three angles are the same in congruent triangles, then they must also be similar. Okay, next question. So what did I do today? 6 so far. And now I'm on to question 8, which is, so when you go to question 8, you're asked to find the volume of a hemisphere. Now, the deal is with a hemisphere is it's exactly half a sphere. So it's half a full sphere. And a hemisphere formula isn't given to you in your tables. So what you do is you get the volume of the full sphere, which is 4/3 pi r cubed when you look in your tables. You can half it now. You can half the 4/3. You can put it into your calculator and go half 4/3 divided by 2 is 2/3. You could use 2/3 pi r cubed, I generally tend to just get the volume of the sphere and then half the answer. So that's what I tend to do. So in this case, the radius of the sphere will be 3 because it has to be the same as the cylinder below it. So this distance in every direction is the radius, it has to be 3. So what we're going to do is V equals 4 over 3 pi times 3 cubed. You enter that into the calculator and you get 36 pi centimeters cubed. Now that's for the full sphere, so I'm going to half that. So therefore our hemisphere equals 18 pi centimeters cubed, right? So you could do 4 over 3 pi 3 to the power 3. And then you just divide it by 2, get your 18 pi. Now, the volume of the cylinder is 36 pi meters cubed. Work out the height. So you go to your tables and you find the volume of a cylinder, and this is the formula you get. Okay. The goal of the question is to find out what is h. The goal of the question is to get h on its own. Okay. And we know that the radius is 3. So it's going to be 3 squared. So pi times 3 squared, if you put it into the calculator, is 9 pi. So you get 9 pi h equals 36 pi. If there's a pi on both sides, they cancel because you can divide both sides by pi, essentially, and you're cancelling both sides, all right? So whatever you think. Or you could do it if 9 pi is multiply on the left, then it's division on the right, and then you can see that the pi's will just cancel, and you get 36 divided by 9, which is 4 meters. Okay. That's a handy start off to that question. Now we're on to part B. Part B looks pretty difficult, okay? We're dealing with a cone here, okay? And cones can be quite a difficult question, okay? The diagram below shows part of the base of a lighthouse, not the scale. It is in the shape of a cone of radius 7.5 meters, from which the top part has been removed. So in the actual lighthouse, the top part has been removed. Work out the height of the cone before the top part is the height of the cone before the top part removed is 47 meters. So see this line here, this big blue line here? That's 47 meters. And this blue line and this green line make a 90-degree triangle. Okay. Work out the size of the angle marked A in the diagram. Now, we're going to use SOHCAHTOA. So silly old Harry. This means sine x equals opposite over hypotenuse. Chase that horse. Cos x is adjacent over hypotenuse. True or attic means tan x equals opposite over adjacent, right? Now we have to figure out which one of these we're actually going to use. So, generally speaking, in the right angle triangle, the longest side is the hypotenuse. And if you were to use your ruler, the red side is the longest side. You're not going to use that. The two sides you know, however, if you picture the angle like an eyeball, it's looking at the 47. So the 47 is opposite it. And then the other one, by process of elimination, has to be adjacent. We have opposite and adjacent, which is O and A. This means we should use tan. The angle we want is A. So tan A equals opposite, which is 47, over adjacent, which is 7.5. Now, the only way to get an angle question done is using what's called inverse functions. So you go shift tan inverse 47 divided by 7.5, and lo and behold, you get an answer of 80.93. So A equals 80.93 degrees, and that's how you do angle questions in trigonometry. Happy days. Now let's see what they want from me in part 2. Find the distance marked k in the diagram. The height after the top part is removed. Ouch. The top part is removed. Now this is a tricky question, okay? Now I'm gonna just rub out all this stuff here. And I'll show you how I'm gonna do it. I'm going to do it using similar triangles actually, okay? So you might not remember this, but it's the way we have to do this one, right? So I'm just going to grab this here. I need this diagram on the next page. Okay, I'll send it to my current page. I'll reduce the size. Okay. Now, here's what we're going to do. Okay, to do this question. We're going to use what's called similar triangles for me to figure out what k is. Okay, up. Do. Cut. Paste. All right, here it is here. Okay, now here's what I'm recommending. I'm claiming that this triangle here, which I will do in blue, this triangle here in blue, which has a height of, for argument's sake, I'll just call it a height h. So everybody sees h. So I'm claiming that h plus k equals 47 because k would be this purple part here and h would be this yellow part here. H and k combined have to equal 47. It's the first thing I'm going to know. Now, this blue triangle here is actually a similar triangle to this red one here. Both triangles are actually the same and have the same angles. Okay, because they're both part of the same triangle system. Okay, so that means they're in proportion. So if this is 7.5 and that's 3, and this is 47, and this is h. Okay, so this one, that's h there. Okay, what we're going to do is we're going to get 7.5. We're going to put the big triangle divided by the small triangle, okay? So we're going to do big over small. So 7.5 divided by 3 is 2.5. So what I'm claiming is that the red triangle is 2.5 times bigger than the blue triangle because it was 7.5 over 3. So this means that 47 is 2.5 times bigger than h. So h equals 47 divided by 2.5. And we get 18.8. Okay, so h equals 18.8. H equals 18.8, such that 18.8 plus k equals 47. So k must equal 47. Take away your 18.8. This means k equals 28.2. Happy days. Now, assume that Fastnet Lighthouse can be seen anywhere within a circle of radius 50 kilometers. Okay, so you imagine this dot represents your lighthouse. Okay, and everything outside this lighthouse, any 50 kilometers in any direction, and you can actually see that lighthouse. Any ship that's on this circle can then see the lighthouse. If you're outside the circle, the lighthouse isn't visible yet, just like from a helicopter view into the ocean. Okay, work out the area. So it's just pi r squared. Okay, so it's going to be pi times 50 squared. Throw it onto calculator. This is actually a reasonably easy question, considering all the other questions was pretty tough. And you get 7,853.98, which rounds up to 7,854 kilometers squared. Now, see part 2. What does that look like? Now, 50 kilometers equals 27 nautical miles. Use this to work out how many kilometers are in 1 nautical mile. Okay. 27 nautical miles, or N, equals 50 kilometers. N equals 50 divided by 27. 50 divided by 27. 1 point. Now, don't let that point 1 fool you. See the dots above it? It means A51, A51, A51. Okay? And what we're looking at is we want to round this one. We want to round this one to 4 significant figures, all right? So currently it's on 5. How many significant figures? 1, 2, 3, 4, 5, 6. That's 6 significant figures. Now I'm going to round it off to, I'm going to round 85 up to 90. And then just get rid of 0. That's 5 significant figures. Now I'm going to round up 19 to 20. And once again, get rid of 0. And that there will be 4 significant figures. So 1.852 kilometers per nautical mile. Okay, there we go. So that's question 8 done. And that's all we have to do today.